Okay, section 5 is about radical equations and its applications. Okay, here is one property that is about raising each side of an equation to the nth power. Okay, so here is an equation, a equals b. Then since this equation, we can raise each side of equation to the same power. So in a to the nth power, then you have to raise right side of the equation to the nth power. So when we solve an equation that has one radical like this, in example 1, okay, we have a 3 square root of x. In order to solve this, we need to rewrite it as x equals something. So this variable x has to get out from the radical symbol. So in that case, okay, rearranged so that there is one radical on one side of the equation and the others are all other terms on the other side. So plus 8 each side, then square root of x is equal to 8. Make sure the radical expression should be on one side. Alright, then this is equal to, now how do we get rid of the square root? We can square each side, right? Square each side. Because this is square root, this is the square root, the index is 2, so we can raise this square root to the second power, okay, square each side. Then this will give you, the left side is only x, the right side is 64. Okay, so 64 is the solution. And then, we have to check, when we square each side, we have to check your solution. So is 64 okay? Okay, plug in 64, then square root of 64. Okay, so let's check it. So square root of 64 minus 8. Is this equal to 0? Then 64 is 8, so 8 minus 8 is equal to 0. So yes, this is okay. So 64 is the solution. Okay, the next one is, this is cube root. Cube root. So why don't, and then also cube root of z is separated. They are in one side of the equation. I mean this radical. So why don't we cube each side? Because the index is cube. So 3, so why don't we cube each side? Then z is equal to 3 times 3 is 9, 9 times 3 is 27. And we got the z value, but always we have to check. So plug in 27, then it should be 3, right? So this is okay. How about the next one? Okay, we gotta multiply. This is fourth root of x. So why don't we, since index is 3, why don't we raise each side of the equation to the fourth power? Then the left side of the equation is just x. And then the right side is 9. 3 to the fourth power is 9 squared. So 81. And is 81 is okay? Is 81 okay? Check. So once you plug in 81, the fourth root of 81, is this equal to 3? Yes, because 81 is 3 to the fourth power. So that is equal to 3, yes. So 81 is the solution. So when we solve rational equation, we always have to check, the radical equation, we always have to check the solution. So plug in the solution into the original equation, make sure that is true. Okay, let's solve this radical expression. Okay, first we gotta move this 6 to the other side. Then this will be square root of 3x equals negative 6. By looking at this, the square root is always has to be positive, but we do have negative, so that is actually no solution, no real solution. Okay, by the way, anyway, as you can see this, there is no real solution. No real solution. I mean, the solution is not a real number. Okay, so let's square each side. Let's square each side. Then this is equal to 3x is equal to 36. Then x equals, divide each side by 3, then 12. We got the value 12. The solution is 12, but we have to check whether 12 satisfies the equation. Okay, check. Then square root of 3x plus 6, is it equal to 0? Let's check. So square root of 3 times 12 plus 6, then this is 36, square root of 36 plus 6, then 6 plus 6 is 12, which is not equal to 0. So 12 is not a solution. It's not a solution. So that there is no solution. So this no solution means no real number solution. That is an imaginary solution, but not the real solution. So it's really important to check your solution, because sometimes the solution that you get does not make the equation true. So in that case, eliminate that value from your solution. Okay, let's do that example 3. Okay, first we gotta get rid of this minus 2. So move minus 2 to the other side. Then this is cube root of 2x plus 1 equals 5. And then what do we do next? In order to get rid of this cube root, we can raise each side of the equation to the third power. Then the left side of the equation is 2x plus 1 equals 5. So that 2x equals minus 1 each side, then 4, and x equals 2. So we got the value x equals 2. Then let's check if this satisfies the equation. Let's check. So cube root of 2 times what? X equals 2 plus 1 minus 2, is it equal to 3? Let's check. Then cube root of 4 plus 1 is 5 minus 2. Okay, 5 plus 1 minus 2. Then cube root of, wait a minute, this is 5, right? So, oh, wait a second, I'm sorry. Okay, 5 cube is not this one. Oh my god. Not this one, sorry. Let's do it again. So 5 cube is 125. Sorry about this. 5 cube is 125. So 2x is equal to minus 1 each side, 124. And divide each side by 2, so that is 62. So we gotta do what? We gotta check this value. We gotta check. So let's go to here. So write cube root of 2x plus 1 minus 2. Is it equal to 3? Let's check it out. So cube root of 2 times 162 plus 1 minus 2. Then cube root of 2 times 62 is 124 plus 1 is 125. And cube root of 125 is 5 cubed. So that is 5 minus 2, which is 3. And this is equal to what? 3. That is true. So yes, this is the solution. Okay, solution is x equals 62. Solution is what? 62. Alright, let's try the next one. Alright, so let's solve this exercise 24. So we gotta move 2 to the other side, then square root of 2t minus 7 equals minus 2 each side, then negative 5. Okay, square root is always positive, but we got the negative. So in this case, we know that there is no solution. But let's square each side and then check whether actually the solution doesn't make the equation true. All right, then this is equal to 2t minus 7 equals negative 5 squared is 25. And then 2t equals plus 7 each side, then 32. Then t equals divide by each side by 2, so 16. So let's check if 16 is okay. So from this one, square root of 2 times 16 minus 7 plus 2. Is it equal to 3? We don't know, right? We don't know. Well, let's check. So that is square root of 32 minus 7 plus 2. So square root of 25 plus 2. Then this is 5 plus 2 is 7. And 7 is not equal to 3. So this is not a solution. Not a solution. So finally there is no solution. Right, there's no solution because from here square root is negative, so there's no solution anyway. So we proved there's no solution. Okay, next one is cube root. So anyway, we gotta move this minus 6 to the other side. Then 4 times cube root of x plus 4 is equal to plus 7 each side, then 8. And from here, we don't need this 4, so let's divide each side by 4. Then cube root of x plus 4 is 2. Okay, then why don't we cube each side? Because this is cube root. So cube each side. And then the left side of the equation is x plus 4 because the index and the power are same. And the right side is 2 times 2 is 4, 4 times 2 is 8. Then x equals minus 4 each side, so x equals 4. And then we gotta check whether this is okay. So from the original equation, 4 times cube root of 4 plus 4 minus 6. Is this equal to 1? Okay, let's check it out. 4 cube root of 8 minus 6. Then 4 times cube root of 8 is 2. Then 8 minus 2 is equal to 6. Okay, and then 6 is not equal to 1. So, is this correct? So, x plus 4 is not a solution. This is not a solution, so there is no solution. So, there is no solution. Alright, in this case, I made a mistake on this. Okay, this is plus 6 each side, then plus 6 each side. Now, why do I write 7? Then this is 7, right? 7. So, actually, this is totally wrong. This is 7. That is 7 cube. So, in this case, I don't think, when I solve this one separately in a scratch paper, it gives out very complicated numbers, the fractions. Because, 7 cube is a large number. And then when we divide this, it's 7, right? So once we divide this 4, and then we gotta raise this to cubed, then the number is large and the large fraction number. So the number is so complicated. So why don't we just skip this exercise? So let me erase this one. Yes, I erased that number 26. And then let's try example 18. Okay, from this one, okay, we can just, the left side of the equation has only one radical, so why don't we just square each side because this is square root. And then the left side of the equation is 18x is equal to 36. And then divide each side by 18. Then x equals 2. So since we have 2, let's check if this is okay. Then square root of 18 times 2 should be equal to 6. Okay, it should be. Then this is 36. 36 is 6. That is equal to 6. So yes. So the solution is, so the solution of this equation is x equals 2. Okay, this example has an equation. This equation has two radicals. Okay, one on one side and the other one is on the other side. So whenever we have two radicals, make sure that we isolate the radicals. So one side of the equation has one radical and the other side has only one and the other radical. So in this case, why don't we, this is square root, so why don't we square each side? So take square each side. Then 5x plus 3 is equal to x plus 11. So we can get rid of the square root. Then simplify this and then solve for x. So minus x each side. Minus x each side. Then 4x plus 3 equals 11. And then minus 3 each side. Then 4x is equal to 8. So x equals 2. We got the value of x, but we have to always do what? Check, right? So let's check so that if this is true, if the equation is true. So 5 times 2 plus 3, is it equal to square root of 2 plus 11? Okay, then this is equal to, the left side is square root of 10 plus 3 is 13. The right side is also 13. So square root of 13 is square root of 13. So that is true. So this is the solution. So the solution of this equation is x equals 12. Okay, this example, this equation has two radicals on one side. So we have to separate one, okay, isolate these radicals. So why don't we move the second radical to the right? Then it will be minus 4th root of 2x minus 4, minus 5. And then we can do what? Raise to the what? Raise each side of the equation to the 4th power because the index is 4. Raise it to the 4th power. Okay, then the left side is 3x is equal to, this negative is multiplied 4 times, then it will become positive. So 2x minus 5. And then minus 2x each side. So x equals negative 5. We got the x value, but we always have to check. Okay. So the solution, we are looking for real solution, not complex solution, real solution, not imaginary solution. So let's check this answer. Then let's plug it in. 4th root of 3 times negative 5 plus 4th root of 2 times negative 5 minus 5. Is it equal to 0? Let's check it out. Then the left side of the equation is 4th root of square root of negative 15 plus 4th root of square root of negative 10 minus 5 is negative 15. And sum of these two is what? Is it equal to 0? No, right? Not equal to 0. So negative 15 is not a solution. Negative 15 is not a solution. So there is no solution. Okay, this equation has one radical, so leave the square root of x on one side, on the left side of the equation, and move 2 to the other side. Then this will be square root of x equals x minus 2. And then what do we next? We have to raise each side of the equation to the second power, right? Because it's square root, so we raise each side of the equation to the second power. Then x equals x squared minus, use the formula, minus 2ab. So 2 times x times 2. So 4x plus b squared. 2 squared is 4. And then move x to the other side, to the right. Then 0 is equal to x squared, okay, minus x each side. Minus x each side, so negative 5x plus 4. All right, so this trinomial is equal to 0. Okay, look at this. When we square each side, this one became a quadratic. Since this is a quadratic trinomial, we can try to make a product so that we can find x. So x times x, 4 is 1 times 4, both negative. Then this is negative x. This product is negative 4x. Sum is negative 5x, same as the second term. So we can write it as x minus 1 times x minus 4. From here, x equals what? Set this factor to 0 and x minus 4 equal to 0. Then x equals 1 or 4. So we got two x values. X equals 1 and 4. Then we have to also what? We have to do checking. So let's say x equals 1. X equals 1. Let's check whether this is correct. So square root of 1 plus 2. Is it equal to 1? Okay, let's check. Then 1 plus 1 equals 3. Then this is not equal to 1. So 1 is not a solution. We know that x equals 1 is not a solution. Okay, what if x equals 4? Okay, let's check it again. So 4 is square root of 4 plus 2. Is it equal to 4? Just replace this x, the 4, the x with 4 from this original equation. Then 2 plus 2 equals 4, and this is equal to 4. So this is, yes, true. So the solution is what? The solution is x equals 4. 4 only. So 1 is not a solution. 1 is not a solution. Only 4 is the solution. So make sure that once we get x, values of x, check each value of x. If it doesn't satisfy the equation, then remove that value from the solution. So in this case, 1 is removed from the solution, so the leftover is 4, because 4 satisfies the equation. Okay, this equation has two radicals and they are separated. So why don't we just square each side? Okay, square each side, then see what happens. The left side of the equation is 3t plus 1, and the right side is, we will use the formula a squared. A squared is 2 squared is 4 minus 2ab. So 2 times 2 terms, so 2 times 2 is 4, square root of 3t, plus b squared. B squared is what? 3t. Okay, should I write it? B squared like this? Okay, that is 3t. So anyway, let's simplify. So 3t plus 1 is equal to 4 minus 4 times square root of 3t plus the third term is 3t. All right, this equation has one radical symbol. Here it is one radical. So why don't we move, isolate this radical? So why don't we move this one to the left and all others to the right? So move this one to the left, and it will be 4 square root of 3t. And then move 3t to the other side. So 4 plus 3t, right? And then move these two to the right and minus 3t minus 1. Then 4 square root of 3t equals 4 minus 1 is 3. And then 3t minus 3t is 0. So we have 3. So what do we do next? Since we have radical, this equation has a radical, so why don't we square each side? Okay, square each side so that we can remove the radical symbol. So that is equal to 16 times 3t. 4 squared is 16, and 3 becomes 3. Square root of 3t squared is 3t. That equals 9. So from here, what is, okay, t is equal to what? 9 over. Okay, let's divide each side by 16 times 3. Okay, divide each side by 16 times 3. Now I don't want to multiply because I just want to divide each side by, okay, divide each side by 16 times 3. 16 times 3. Okay, then we can cancel out 3, so it will be 3 over 16. So we got the value 3 over 16. And then let's check if this satisfies the equation. Okay, so let's check. So let's go over here. Then plug in 3 over 16. So square root of 3 times 3 over 16 plus 1. Is it equal to 2 minus square root of 3 times square root of 16? Okay, let's check. So this is equal to square root of 9 over 16 plus 1. Then square root of 19 over 16 plus 16 over 16. Then square root of 35 over 16. Okay, how about the right side? Okay, 2 minus square root of 9 over 16. And 9 over 16 is what? Square root of 9 over square root of 16. So square root of 9 over square root of 16. So 2 minus 3 over 4. Okay, so that is equal to, okay, over 1, so 8 over 4 minus 3 over 4. So this is equal to 5 over 4. Alright, so let's, okay, this is 25. Sorry about this one. This is 25. This is not 19, right? It's 9. Why did I write 19? So that is 25. So the left side of the equation is 5 over 4. Right, so this is equal to 5 over 4. So yes, 3/16 is the solution. So the solution is t equals 3 over 16. Okay, sorry about this one. So 9 plus 16 was 25. It was not 19. Okay, let's try exercise 38. Okay, this one has one radical on one side of the equation. So why don't we square each side? Okay, square each side so we can get rid of the square root symbol. Then we have x squared minus 4 is equal to x squared. Okay, use the formula a squared minus 2ab. So minus 4x plus 2 squared is 4. Then we can cancel out x squared. So minus x squared. Okay, so let's minus x squared each side. And then plus 4 each side. So 0 is equal to negative 4x plus 8. And then from here, 4x, move 4x, negative 4x to the left is equal to 8. Then x equals 2. So since we got the value x, let's check whether this satisfies the original equation. So square root of 2 squared minus 4, is it equal to x minus 2 minus 2 actually, right? 2 minus 2. Okay, then this is 4 minus 4 is equal to 0, and this equal to 0. So, yes, this satisfies the equation. So the solution is what? X equals 2. Okay, this exercise 50 has two radicals on one side, so let's isolate one of them. So let's move the second one to the right. So that will be 1 plus square root of x minus 1. And then what do we do next? Okay, square each side. So, okay, let me write the second part first, the equation first. so that I can raise each side of the equation to the second power. So raise each side of the equation to the second power, then x plus 3 is equal to a squared is 1 plus 2ab. 2 times 1 times square root of x minus 1 plus b squared. So x minus 1 squared. Then x plus 3 is equal to 1 plus 2 square root of x minus 1 plus x minus 1. And then simplify. Alright, so we have x minus 1 over here, so leave that one and then move others to the left. So minus x each side, then that one cancel out. 3 equals, okay, 1 minus 1 is 0. So we have this. Okay, and then let's square each side. You can square each side or you can divide 2. You can divide the equation by 2, still okay. But let's square it each side. Then this is equal to 9 equals 4. 4 and then what? Okay, 2 squared is 4. And square root of x minus 1 squared is x minus 1. So from here, 9 equals 4x minus 4. And then plus 4 each side. So 13 is equal to 4x. Divide each side by 4. So x equals 13 over 4. Okay, let's check if this value satisfies the equation. Okay, square root of 13 over 4 plus 3 minus square root of 13 over 4 minus 1 is equal to 1. Is it equal to 1? Okay, let's check. So square root of 13 over 4. Okay, 3 is 3 over 1. So multiply top and bottom by 4. 12 over 1. 12 over 4. Okay, minus 13 over 4 minus 4 over 4. Okay, then the left side is still 25 over 4 minus 9 over 4. And the numerator is square root of 25, so that is 5. The denominator is square root of 4, so 2. Same thing. Square root of 9 is 3. Square root of 4 is 2. So this is equal to 2 over 2 is 1. And this is equal to 1, right? 1. So yes, 13 over 4 satisfies the equation. So the solution is what? The solution of this equation is x equals 13 over 4. Okay, this is our word problem. Okay, this is about the amount of power consumed by an electrical appliances is given by these equations. And I is the current measured in amps, and R is the resistance measured in ohms, and P is the power measured in watt. So in this case, we will find the power P. So in order to find P, we know that we gotta know the values of the other variables, I and R. And the I and R are given, so why don't we just plug those values in? So let me rewrite the equation. I equals square root of P over R. And then let's plug in these values. The current is 10 square root of P over the resistance is 16 ohms. So in order to solve this, to find P, we gotta get rid of this square root. So how do you get rid of the square root? We take a square each side. I take square each side. Then 100 is equal to P over 16. Multiply each side by 16. Then this is equal to 1600 is equal to P. So the P value is equal to what? 1600 watts. Okay, you can check this one. Okay, if we check this, then this is okay. Check. All right, that is fine. So the power is on 1600 watts. So when you check, this is okay, no problem. Okay, this example is about the velocity of a free-falling object. And the equation is given, v equals square root of 2gh. So from here, let's find the height, which is the distance that the object has fallen. And we have a values for the velocity and the gravity. So velocity is 50. So let's write the equation. So 50 is equal to square root of 2 times the gravity is 32. The height is h. So h is the value that we want to find out. All right, then what do? We gotta do what? Square each side. So let me write the equation again so that we can square each side. So let's get squaring each side of the equation gives you 2500 equals 2 times 32h. All right, then in order to find h, why don't we divide each side? Okay, so divide each side by what? 2 times 32. 2 times 32. Okay, then we can cancel out the right side, so h is equal to, all right, 2500 divided by 2 is, why don't we use just calculator? Then this will give you 39. Okay, so, we can check this if 39 is okay, but since our calculation is correct, and then the square root is positive, so this will be okay. So when we check, this is okay, right? So the solution, the height is 39 feet. Okay, this example is about finding the distance. Okay, there is an island here, So distance, and then on the land side there is a house and a playground. The distance between the playground and the house is 40 meters. And the house in the island and the playground has 50 meters distance. So in this case, what is the distance from the island to the house? So that this is right triangle. Since this is right triangle and two side lengths are given, we can use Pythagorean theorem. Do you remember Pythagorean theorem? Okay, Pythagorean theorem is, okay, long spelling. Is what? The hypotenuse. Okay, here it is this. Okay, let's say this A, B, C. Then C squared is equal to A squared sum of square of the other two legs. So that hypotenuse squared is equal to square root of A squared plus B squared. So that's the formula. So we can write use the formula to write an equation. So 50 squared. From here, the hypotenuse is 50. So 50 is equal to what? Square root of D squared plus 40 squared. So using the formula, we wrote C squared, which is hypotenuse squared, equals A squared plus B squared, and then take the square root each side. So 50 is equal to square root of D squared and the 40 squared. Then from here, let's find the solution. Let's find D. Okay, so how do we find D? We gotta get rid of this square root symbol, so we can square each side. Square each side. So that this is equal to 2500 is equal to d squared plus 40 squared. And then 40 squared is what? Okay, 1600, right? This is 1600. And then d squared is equal to minus 1600 is 900. Minus 1600, 900. Then what do we do? Okay, here's a good. We have a formula, but let's use difference of squares. Okay, so 0 is equal to d squared minus 300, and from here, d squared minus 300 is what? 330 squared is equal to 0. Interchange the side. Then this is difference of squares, so d plus 30, d minus 30 is equal to 0. And then we set each factor to 0. Then d equals negative 30, or d equals 30. So in this case, the distance is always positive, so we'll eliminate negative 30 from the solution. So d is what? 30 meters. Okay, in this case, we use difference of squares, but we can use a formula like this. We will learn this one next time. The formula is this. If, x squared, let's say x squared is a, then x is equal to, get rid of this power so that the base x is equal to plus or minus square root of a. Okay, so there it. So x value is either positive square root of a, or x is negative square root of a. Okay, this is a formula. It's much easier to write the solution. If we use different squares, it takes time and there's more work. So next time we have x squared equals something. Then we can get rid of this power 2. Get rid of this power 2. So that the base is equal to the right side of plus or minus the right side square root of the right side. Okay, like this.